right, so when we are factoring, no matter what the original problem is, the very first thing you have to do is look for a GCF. Now, we've done a lot of problems that didn't have GCFs, but technically everything we factor could. So no matter what, you check for your greatest common factor. After that point, what we do kind of depends on the number of terms you have. So remember, terms are separated by addition or subtraction signs. So we look for GCF. And then, if it's two terms, we check to see if we can do a difference of squares. So remember, difference of squares, two perfect squares with the subtraction in between. If you can't factor anything at all, what do we say? Prime. So anything that cannot be factored is called prime. If you can do like the GCF, but then you can't do the next step, it's not prime because you were able to factor in some way. So if you can do anything at all, even if it is only the GCF, then it is not prime. However, we've seen that sometimes we can do multiple things. We can take out GCF and then do difference of squares, so we have to check. I'm sorry, that's really annoying if it doesn't quit trying to zoom in and out. So, the difference of squares, remember, factors the same every time. You have two parentheses. So x squared minus 64. Does it have a greatest common factor, first of all? No. So then, is x squared a perfect square? Yes. Is 64 a perfect square? Yes. So we have two identical parentheses, except one has plus and one has minus. What is the square root of x squared? And the square root of 64? So it's x plus 8, x minus 8. And how can you check every one of these problems? Distribute it back out. Okay, the second one. Do we have a greatest common factor? 2 and n. So we take out that 2n. Now when we take it out, it doesn't disappear, it just comes out in front. So 18 divided by 2 is 9. We have m squared, we took out the n, so that's gone. 2n cubed, if I take out 2n, what are we left with? 1n to the squared, yep. So whether or not you write the 1, it doesn't matter, but you have to make sure you have your square. Okay, if I look, this is still two terms. If it's two terms, we check. Can we do difference of squares? Is 9m squared a perfect square? Yes. Is n squared a perfect square? Yes. So this one will factor further. So the 2n stays. So 1 is plus and 1 is minus. The square root of 9m squared is 3m. And the square root of n squared is n. So we get a 3m plus n and a 3m minus n. All right. If we have three terms, we still have to start with the GCF. So then if three terms, that's our trinomial. So that was our slip and slide, or sometimes we had easy method. So this first one, do we have a greatest common factor? So the x squared, oh, sorry, on the other one we do, but on this one we do not. So remember our strategy on these, we were looking for two numbers that multiply to negative 42 and add to negative 1. What would those be? Negative 7 times positive 6 is negative 42. Negative 7 plus positive 6 is negative 1. So when this factors, we had x squared, so we put 1x in each of them. And then we have a minus 7 and a plus 6. And it doesn't matter the order. So if you put the x plus 6 first and the x minus 7 second, that's fine. What about the second one? We can take out a 2. So that leaves us with w squared plus 10w plus 25. So now this is 3 terms. It's a trinomial, so we're checking to see. Do we have 2 numbers that multiply to a positive 25 and add to a positive 10? 5 times 5 is 25, 5 plus 5 is 10. So the 2 stays, 2 parentheses, so w squared breaks into w, and we have a plus 5 and a plus 5. All right, so far remembering doing these? Okay. 2 more. If I look at this problem, what's the first thing I need to look for every time? GCF. I have 3 terms. Does anything divide all of those? Positive 3. So 30 divided by 3 would be a 10x squared. Minus 27 divided by 3 is a 9x. Plus 6 divided by 3 is 2. Now what do we have to do? Slip and slide. Because it's not just a 1x squared, we can't go straight into the shortcut. We have to do our slip and slide. So we slide the 10 down. 10 times 2 makes 20. So now I need numbers that multiply to positive 20, add to negative 9. Negative 5 times negative 4 is positive 20. Negative 5 plus negative 4 is negative 9. So we have x minus 5, x minus 4. Now what could we do? Or what do we need to do, I should say. Yes. Okay, so 5 over 10 reduces to 1/2. So you slide the 2 back in front. So we have a 3, 2x minus 1. This one, 4 over 10, reduces to 2 over 5. So the 5 slides back in front. So 5x minus 2. All right, so that one we had a greatest common factor and slip and slide. The final one. So we talked about what to do if you have 2 terms. Greatest common factor, difference of squares. 3 terms, greatest common factor, slip and slide. 4 terms, we always still check for greatest common factor, but then we go into grouping. So if I look, this is 4 terms. Is there anything that would divide all 4 of those numbers? No. So we group them. We put the first 2 in the parenthesis and the second 2 in a parenthesis. Remember, you can't add a parenthesis after a negative. So if this were a minus right here, you would make it plus a negative 10 before you added your parenthesis. So now in the first parenthesis, what can we take out? A squared. If you take out a squared, you are left with Second one, what do we have to take out? So 10a divided by 5 would be a 2a, minus 5b divided by 5 is just b. We know it works if these parentheses are the same. Sometimes you might have to go and pull a negative out of one of them to make them match. Since they are the same, we factor that out. So we're taking out that 2a minus b. And it's times because it's factored, so the second parenthesis is what's left. So we have the a squared left in the first one, and the second one was a plus 5. Any questions there? So those are all the different strategies. Greatest common factor first. Your next step depends on your number of terms. So now we